let's draw a function that seems to come up quite a bit, which is the ramp function that is squared divided by 2. So in this case, we have t plus 3, so it's going to be 0 into that point. And then it's going to follow the trajectory of a squared. Now the thing is really if you bring it to wherever it's going to start being non-zero, like if it was here, or if it was -3 here, or 1, they all follow the same trajectory, is of 0 gives 0. If the difference in time, if the difference in t and the delay is 0, it's 0. If it's 1, it's 0.5. If it's 2, you get 2. If it's 3, you get 4.5. And 4, you get 8. So really, in this problem, the sequence is always going to be, it's going to go up to 0, a half, 2, 4.5, and 8. So it's positive. So I'm going to single click on -5, all, and single click here on 3. Then I go up a delta of 1, right? So t plus 3 minus 2, right, gives me a delta of 1, and that's about a half. I'm just going to single click here. Then I go over another one, which will give me 2. Then I will go over another one, which should give me 4.5. And now this one's might be a little bit hard, but if I go over 1, I should be at 8. So I am just trying to make the slope sharper. And I'm just going to double click and submit. So this is, again, generated fairly loosely. And in fact, I think if you started here, went to -3, right, and put in just a ramp function, it will give you some points, right? It's not right, but it'll give you something. But really, I'm just going to move this a little bit. So this is -2, so it's 0. I go all the way out to now it's a delay of 2. Single click on the 2, and then I just, it's positive, so I'm just going to follow the pattern. I go over by 1, it goes up a half. I go over by another 1, it goes to 2. I go over by another 1, it goes to 4.5. Snap to grid isn't set. Be a little bit hard to do, but I think you get the idea. That's it.